Dextrose solutions are for giving water and a bit of nutrition. Primary use is in the treatment of hypernatremia and hypoglycemia, and they have a secondary use as maintenance IV fluids. The primary thing to keep in mind with dextrose solutions is that they distribute across the total body water, and they distribute in the same ratio as total body water is distributed across the three compartments. And so if you give a liter of D5W or any dextrose solutions, 670 or 2/3 of that fluid will end up in the intracellular compartment, 250 ml will end up in the interstitial compartment, and only 80 ml remains in the plasma compartment. So when you compare it to the three IV fluids, dextrose solutions are at one extreme with the minimal amount remaining in the plasma compartment. Dextrose solutions really distribute just like a glass of water. So why don't we do infusions of sterile water? Why don't we give sterile water? Why do we need dextrose solutions? So sterile water is extremely hypotonic, and this would result in a rush of fluid inside the cells. Most importantly, it would cause a rush into the red cells in the very veins that the IV fluid is being infused in. And if they stretch the red cells out too much, they would rupture, causing hemolysis. Hemolysis looks something like this in a blood draw. You can see the serum here is stained red from all the hemoglobin leaking from the red cells compared to a normal. But more importantly and critically here is that same hemoglobin spilling into the urine, and that hemolysis can cause anemia and acute kidney injury, possibly requiring dialysis or death. So how sweet is D5W? If we add glucose to prevent that hemolysis, how much do we need to add? Well, D5W is 5% glucose. That means 5 grams of glucose per 100 milliliters or 100 grams of solution. This is 5 grams per deciliter. 100 milliliter equals 1 deciliter. And if we convert grams to milligrams, we get 5,000 milligrams per deciliter, and that's the conventional units we use to measure glucose. Now, D5W is a glucose concentration of 5,000. That's incredibly high. And if we wanted to figure out why, we need to convert that to the units of osmolality. To do that, we would divide by the molecular weight of glucose and then multiply by 10. 5,000 divided by 180, multiplied by 10, comes out to 277 millimoles per liter. Compare that to normal osmolality of 275 to 295, and you have isoosmotic fluid here. And so here, when you give D5W, there's no net movement of water in or out of the red cells.